Okay, in question 5, we're asked to consider a scenario in which somebody is, well, me, I'm trying to push my van up the hill, and somebody's inside trying to press on the gas pedal. The wheels are spinning forward in place, so there's a lot of ice here, and these wheels are turning like this. So the fact that the wheels are turning forwards means that the van is not in reverse. The wheels are spinning forwards, van not in reverse. Now, we're asked, why is there a danger that the van might slide back? Well, let's consider each of our choices, having eliminated that first one. When spinning the tires, the kinetic force of friction is less than the static force of friction, always. And lowering this frictional force allows the car to slip. So if before we started spinning the wheels, the car was stationary, then Fs, our static force of friction, was large enough to hold the van. But spinning the wheels might possibly lower that force of friction. We know that mu k is usually less than mu s, the static coefficients of friction. But Fk, the static force of friction, is equal to mu k times the normal force. And Fs is less than or equal to the static force of friction maximum, which is equal to mu s times n. So Fs is greater than or equal to 0. Fs can be less than the kinetic force of friction, or it can be more than the kinetic force of friction for a given surface, depending on how hard we're pushing and how much force of friction is required to stop an object from sliding. So the problem with this answer is saying the word always. Sometimes the kinetic force of friction is bigger than the static force of friction, and sometimes it's less than the static force of friction because this is an inequality. So this answer is wrong. It could be that there's no danger, but it might not be. Is the static force of friction always less than the kinetic force of friction? Well, no. If the coefficient of static force of friction is bigger than the kinetic coefficient of friction, it's possible for the maximum static force of friction, if the force of friction gets as big as the maximum static force of friction, for the static force of friction to be bigger than the kinetic force of friction. So that answer is not possible either. And so we're left with just two choices. Now, the weight of the car is something that's really big. And if we were to draw a free body diagram for this car, the weight of the car is actually pointing downward. Our angle here is theta. And so the component of the force of friction that's pointing down the hill would be the weight of the car times the sine of theta. So if the weight of the car times the sine of theta is bigger than the kinetic force of friction and the force that I'm pushing up the hill with, then it is possible for this van to start sliding down the hill. And because both the kinetic force of friction and the static force of friction depend on the normal force, and the static force of friction maximum is generally going to be bigger than the kinetic force of friction. But because they both depend on the normal force, which is going to be really large for a car, and not really large for me, my force is going to be puny compared to, or very small, compared to the other frictional forces. So it's quite likely that it's possible that if the car was close to the point of slipping, that this could be satisfied. Was initially close to slipping. Fs max might be big enough bigger than the weight of the car times the sine of theta, or equal to it, and it's possible for this secondary thing to be true too.